In this video, we will be graphing and analyzing this rational function. The first thing you should do is factor this thing and make sure nothing cancels out or anything. So I can already tell that nothing is going to cancel out, but let's follow through. This is the difference of two squares in the denominator. So this would be x plus 5 times x minus 5. And then in the numerator I have x squared. Nothing cancels out. So that means there will be no holes. Alright, since holes happen when something cancels out. So for holes I can just go ahead and put none. Alright, now let's jump back and talk about the vertical asymptote. Alright, the vertical asymptote, you know what, I'll call that VA, vertical asymptote. You get that by setting the denominator equal to 0. Alright, so if I set this denominator equal to 0, I'm going to wind up setting the two factors equal to 0. X plus 5 equals 0, x minus 5 equals 0. That's going to give me x equals negative 5 and x equals positive 5. So those are my vertical asymptotes. Don't just put negative 5 and positive 5. Put x equals negative 5, x equals positive 5. Let's go ahead and graph these vertical asymptotes on the graph. Alright, so there we have graphed those vertical asymptotes. What's next? Horizontal asymptote. The horizontal asymptote is all about the degree of the numerator compared with the denominator. This is degree 2 and degree 2. Since the degrees are equal, the horizontal asymptote will come from the leading coefficients. 1 over 1, which is 1. So that's why the horizontal asymptote is going to be y equals 1. Don't just say 1, say y equals 1. Alright, let's go ahead and graph that horizontal asymptote. Alright, so we've got our vertical asymptotes, we've got our horizontal asymptote. What's next? Slant asymptote. Well, a slant asymptote happens when the top degree is one more than the bottom. That's not the case here. They're the same. So there will be no slant asymptote. So for slant asymptote, I will simply say none. X-intercepts. For the x-intercept, you set the numerator equal to 0. So if I set x squared equal to 0, if I take the square root of both sides, I get x equals 0. That means my x-intercept, which is always something comma 0, in this case it's going to be 0 comma 0. So my x-intercept will be 0 comma 0, and we should go ahead and graph that point. Alright, so there's my x-intercept. Now my y-intercept is also going to be 0 comma 0. I know because it's on 0 comma 0 is on the y-axis as well. But in general, let me just follow through. Okay, if I wanted to find the y-intercept, all right, you get the y-intercept by plugging in 0 for the x's. Okay, so for the y-intercept, you let x equal 0. So if I let x equal 0 here and here, that would be 0 squared over 0 squared minus 25. Well, 0 squared is 0, so I have 0 over 0 minus 25. That is 0 over negative 25, which is 0. Okay, and the y-intercept is always 0 comma something, but in this case we know that the other something is also a 0. Okay, but we knew that ahead of time. So there's our y-intercept, but I guess we should write it down. Now, to do the domain and range, we need to actually graph some points. All right, the vertical asymptotes really tell us what x values we need to use. Okay, we have a vertical asymptote here at -5. Okay, and we have one at +5. Every vertical asymptote is going to give you 4 x values that you need to use. Let me just do this really clearly. All right, the vertical asymptotes tell you what points you need to use. Okay, so let's make a number line. We have a vertical asymptote of -5. Now, imagine I went to the left and imagine I went to the right. This would be -6 and this would be -4. So those are 2 of the values I need. But also, if I went halfway, this would be -5.5. We also need that. If I went halfway right here, that would be -4.5. So these 4 pink values are the ones I need, from -6 to -4. Oops. So let me record those values so far. So I know I'm going to need -6 and -5.5 and -4.5 and -4. I need those 4 values for sure. Now I got those 4 from -5. Now how about +5? I'm going to do the same thing. Okay, if I have +5 for my other vertical asymptote, imagine going to the left and to the right. To the left I have 4, to the right I have 6. In between I have 4.5 and 5.5. So these are the other 4 values that I need, the pink ones, not including the vertical asymptote. Okay, I just forgot what I was doing for a second. So I'm going to write those values down as well. So I'm going to have 4, and I will have 4.5, and 5.5, and 6. So these are the values that I'm going to need. I'm going to get these values off my calculator. Alright, if memory serves, nothing canceled out. Am I right? Yeah, so nothing canceled out. So I have x squared over x squared minus 25. And I'm going to use ask x mode. Alright, so I need -6, and I need -5.5, and I need -4.5. Alright, these are some pretty weird decimals, so weird fractions. So I really need the decimals for my chart here, so I'm going to toggle each one. So if I hit the toggle, I see that it's negative 3.3. I'm rounding up. Did I say negative? Positive 3.3. Alright, if I look at the next one, toggle it, that is positive 5.8, rounding up. Alright, I'm going to just keep doing that, and I will get all the y values. Alright, so these are the values that you get. Now I'm just going to plot all of these points on my graph. Alright, when I graph those 8 points, this is what I got. Remember, this one was my x and y intercept. So, over here in this part of the graph, I know the curve has to pass through these points and approach the asymptotes. So it's going to be doing this type of a thing. Something like that. Meanwhile, in this part of the graph, it's going to be passing through these points and approaching the asymptotes on either side. So it's got to be doing this type of a thing. And on this portion of the graph, it's got to approach the asymptotes on either side while going through those points. So your graph should look very much like this. Now let's go ahead and talk about the domain and the range. So the domain goes from left to right, but it breaks at these vertical asymptotes. So the first portion of the domain goes from negative infinity to negative 5. And then it's the second portion of the domain goes from negative 5 to positive 5. And then the third portion of the domain goes from positive 5 to infinity. Basically, I have to skip over the vertical asymptotes. All right, but those are my x values that are covered by this graph. Okay. So what did I say? Negative infinity to negative 5. Negative 5 to positive 5. Whoops. And then 5 to infinity. All right, many students have a little bit more trouble with the range. So let's be very careful about the range. When we talk about the range, we are talking about the y values. So it's what are the y values of this graph? Let's do this from bottom to top. So I'm going to trace on the y-axis wherever the graph goes. So the graph starts down here at negative infinity, and it goes up until it gets to here, and then it stops. It picks up again after the vertical asymptote, but the bottom portion of the graph goes from negative infinity to 0. It doesn't go all the way to the horizontal asymptote. So negative infinity to 0 is the first part of the range. Alright, it is going slow today. Okay, so negative infinity to 0. I'm going to put a bracket on that because at 0, there's no asymptote here at 0. The graph touches 0, so that's part of the range. And then there's a little gap, but the function picks up again after the horizontal asymptote. I'm looking at both of these at once have the same y value. So these y values start at 1 and go up from there. So this part of the graph goes from 1 to infinity. So that's the second portion of the range, is 1 to infinity. And I am going to use parentheses, not a bracket, because at 1, this is an asymptote. The graph doesn't actually touch 1. There are no y values at 1. All right, what else do we need to do? Oh yeah, we need to talk about increasing and decreasing intervals. All right, watch this very carefully. Now, most students understand that when the graph is going uphill, that's increasing. So for example, this portion of the graph is increasing because this portion is going uphill. But what are the x values of this? Because that's what you're going to record as the interval. So this increasing portion of the graph goes from negative infinity to negative 5. It stops at the vertical asymptote. So negative infinity to negative 5, that's an increasing interval. Okay, let's see what's next. Okay, now after that, the graph jumps down here. This portion of the graph is also increasing. All right, it's going uphill from left to right. But what are the x values? All right, this portion of the graph on the x-axis goes from negative 5 to 0. Negative 5 to 0. Those are the x values. So that's increasing from negative 5 to 0. All right, and then it begins decreasing. All right, so from here down, the graph is decreasing. But what are the x values? All right, this decreasing portion of the graph, if you look at the x-axis, it goes from here to here. It stops at the vertical asymptote. That is 0 to 5. So that is a decreasing interval from 0 to 5. Then the graph jumps up here. And again, the graph is decreasing downhill. All right, this is decreasing. But what are the x values? On the x-axis, this decreasing portion begins here and ends here. All right, it begins after the vertical asymptote. So that is 5 to infinity. So that's what you record. So this decreasing interval is from 5 to infinity. Notice that for increasing and decreasing intervals, we use parentheses the whole time. The reason is because, for example, look at this point right here. It is increasing from negative 5 to 0. It's decreasing from 0 to positive 5. Right at the point in the middle, it's neither increasing nor decreasing. It's flat on top. So you can't include the point where it changes. All right, that just leaves end behavior. When there's a horizontal asymptote, the end behavior is super easy because the function always approaches the horizontal asymptote. Now, end behavior only pertains to the far left and the far right. So when we talk about end behavior, we're talking about the far left and the far right. On the far left, the graph approaches the horizontal asymptote, 1. On the far right, the graph approaches the horizontal asymptote at 1. So whenever there's a horizontal asymptote, that's going to give you the end behavior. As x approaches negative infinity, meaning on the left, the graph approaches 1, the horizontal asymptote. As x approaches positive infinity, meaning as we go to the right, the function again approaches 1, the horizontal asymptote. And that is it for problem number 2.